Hi students, this video is a continuation of your previous video, design and implementation of your half adder. So in previous video we have designed your half adder and we have obtained a logic circuit from the statement. Okay, so in this video we are going to implement using your digital trainer kit. So for that, before moving into your implementation, first make a plot which are the pins you are going to make use of from which of the ICs. As you all know, this is your XOR gate and this is your AND gate. XOR gate, to have this function to be implemented, it could be done only with the help of your IC 7486. And to have the function of your AND gate, you have to choose your IC 7408. So for this, before giving the connections, you should know or you should be aware of your pin diagram of those ICs. So this is your IC 7486, which is a 2-input IC gate, XOR gate, which encapsulates 4 gates within itself. So that is why the name quad 2-input XOR gates. Okay. So this is the structure of your pin diagram IC 7486. Which has 14 pins altogether, 7 this side and 7 to be plotted this side. So starting always from the dip. So when you pick up the IC, you have to look for, on the top side, you have to look for the dip, and over that you will have a small plot like this in your IC. From there on you have to count it as IC number, pin number 1, 2, 3, 4 and so on. So as I've told you already, on one side you will have 7 pins, on the other side you will have the remaining 7 pins. So this is the way you have 4 gates to be, XOR gates to be encapsulated. Look at the direction also, because out of the basic gates and your universal gates and this special gates, only one IC have the gates to be facing upward. Whereas for all of the remaining ICs, the inside gates which are encapsulated would be facing this side. That is from 1 to down. Wherein in one IC you will have all the 4 gates to be facing upward. Okay. So the direction of connection, everything is very, very important. So coming to the pin numbers. Pin 1, 2, 4, 5, 9, 10, 12, 13 would be always your input pins. And pin 3, 6, 8 and 11 would be always your output pins. So if you have started a connection, like if you have opted for a output pin 11, then you should fully consume the gate 13, 12 with the inputs. You should not give a output over here connected, and you can't have your inputs signals to be connected over this gate. Then you won't have an output. So if you choose your output pin to be either 3 or 6 or 8 or 11, the consecutive input pins has to be consumed. So that is very, very important. Okay. So people usually make mistakes in this. So here I have chosen this gate, first gate. I'm going to, because your half adder involves only one XOR gate. In your circuit you would have noticed. Here look into this, you will have only one XOR gate, not more than that. So in that IC I'm going to consume only one XOR gate with a pin number 1, 2, 3. So this is how I have written the pin number to be 1, 2, 3. If you are going to make choose of your 4, 5, then 4, 5, 6 it should be. You can't have 4, 5, 3. Then it would be a wrong pin connection. Okay. So similarly, looking for your IC 7408. This is your AND gate IC. Here also you have 4 gates to be incorporated within it. So that is why again you have the name quad 2 input AND gate IC 7408. Here also based on the dip you can start counting your pin numbers. Here also it is going to be your 14 pin IC. One side you will have 7 and the other side you will have remaining 7 to be connected. And always remember, for any of the ICs you will have 7th pin to be ground and 14th pin to be your VCC. Here also you could have noticed your 7th pin will be ground and 14th pin would be your VCC. Okay, so here also the same kind of structure and the flow. 1, 2, 4, 5, 9, 10, 12, 13 would be always your inputs for your AND gate, and 3, 6, 8, 11 would be your output pins. Okay, so here also I have chosen the first gate, set of gate for my half adder. So that is why I have written it as 1, 2, 3. Okay, so now you are aware of why I wrote this connection, pin connection, and you also insisted to write the same while drawing your logic circuit diagram. So now we will start on with our implementation. So first pick out your trainer kit. So this is your digital trainer kit. Herein you have to plug it and then you have to switch on the power supply. Here you have to make a switch so that your kit will be on, and thereafter remember always this is your power supply unit wherein you can look into it. 5 volts you have, 15 volts also is there, and then you have a common ground. From this also you can take your ground from the kit, or else you can off from your breadboard. So always this side of panel would be your input switches. These are switches. Okay, so based on this, if you connect your wire and if you can on and off, that means you can give the input and you can disable it. Here you could see the outputs. So as you know, my circuit involves only 2 inputs and 2 outputs. What are the 2 inputs? A and B, and my outputs are sum and carry. So in the input panel side, I have to choose 2 inputs as your switches and your 2 outputs, 2 LEDs to show or blink with your LEDs. So now these are my ICs, IC7486. This is my IC7486. So here the number would be written on the top. So based on that you will make a selection and you will fetch the IC from your lab assistant. And again, next, this is your IC7408, this is your AND IC, and this is your XOR IC. Okay, as I've told you, I've chosen the first slot of gates. So IC pin number 1 and 2 will be connected with the inputs A and B. So this is your input A with a white wire connected to the one switch, and this is your next input B connected to the another switch. Okay, and similarly, I have my input. Here I have tapped for the next gate also, AND gate, to have my carry output. This is your, from here I have tapped it. From here, input A, already it has been connected with my XOR. So from that I have tapped it to my AND gate. Next, input B, again I have tapped it from the second slot. And thereafter you have to remember, don't forget to connect your VCC. What is your VCC? 14th pin. This is your 14th pin. So VCC, and you have to connect it with your supply. So this is your supply VCC. We have taken it commonly over here, or else you can give straight away over to the 14th pin also. It will work on. Okay. So I have taken it commonly. From there I have connected to the 2 ICs over here and over here. Okay. You can have a look. From here I have made a tapping to both of my ICs. And similarly you are going to take the ground from the kit, and I've given it over here commonly. From here I have given the ground connection, 7th pin over here. I have tapped it from the common. Okay, so my power supply connection is over. My inputs are connected to both the ICs, and now my output pins. What is my output pin for my XOR gate? 3rd pin, and even for this AND gate, the 3rd pin. So 2 outputs has been taken over here. This is your sum and this is your carry. So now based on the inputs which I am going to switch on over here, my output has to glow. And you know the truth table already. That is, for your half adder, your A B, when both the inputs are 0, 0, my sum and carry should be 0, 0. 0, 1, na, my sum should be high and carry should be 0. 1, 0, na, my sum should be high, carry should be low. And when both the inputs are 1, 1, my sum would be 0 and my carry would be generated. So this is how it has to glow. So this is the truth table of it, which I have shown it already in your previous video. So just for a reference, I have written here. So now coming to the function, whether it's working or not, we will check. So when now the board is on, when both are 0, my sum and carry are 0, 0. When A is 0 and B is 1, my sum is glowing. So I have an output 1. And when B is 1, my sum is again glowing, my carry is not glowing. Look at this carefully. Okay. And when both are 1, I have my carry LED to be glowing and my sum is not glowing. So the circuit functions properly. Okay. So this is how you have to check it, and this is how the simple half adder circuit works. Okay. So kindly have a look and then you also try for the same. Once again I am trying to execute. My sum is glowing for all other combination, and when both are high, my carry is glowing. So with this, your half adder circuit is over. So in the next session we will see the full adder circuit. Thank you.